All right, what's that?
Usually you ask, do you have like the situation up above?
Oh, no, these are three separate questions. Oh, sorry, I didn't mean to be tricksy. That was not my intention. I apologize. All right, let's take a look at these three questions. Which one of these motions is not a constant acceleration? A rock falling from a cliff, an elevator moving from the second floor to the fifth floor, making stops along the way, or a dish resting on a table? What all did you say?
Elevator.
Throw an answer out there.
Elevator.
Elevator moving from the second floor to the fifth floor, making stops along the way, not constant acceleration?
No, because it stops.
It stops and it speeds up and it slows down and it speeds up and it slows down. So there's a lot of acceleration in the positive and negative direction. I would agree. How about the rock falling from the cliff? Is that constant acceleration? Indeed it is. And the dish resting on the table?
Yeah.
Acceleration of?
Zero.
Zero? Cool. Can an object have a velocity, a zero velocity and a non-zero acceleration, again, relative to, if we call this reference frame our rest reference frame? What do you say? Can an object have zero velocity and non-zero acceleration?
Yes.
Yes, says that table, but they're loud. Can somebody else give me an example? Oh, I'm just going to rely on them to talk. Or do you disagree? You could say no also. That's okay. You don't have to agree with them. Do you guys have an example for that one? Can an object have a zero velocity? Did we stump you? Do you think the answer is yes? Yeah? So why do you say yes? I suppose.
So like if my car is rolling backwards down a hill and I push on the gas so it's accelerating up the hill, there'll be a point where it's not moving at all, but it's still accelerating upwards.
Does that make sense? Did you guys catch? Because you're kind of quiet. You said loud one time.
Okay. So if my car is rolling backwards down a hill and I start to push on the gas, it'll be accelerating up the hill, and there will be a point where the car's not moving at all, but it's still accelerating upwards.
Yeah.
Does that make sense? Yeah. And eventually, after it stops moving, then what's it going to do? It's going to go up the hill, right? Yeah.
Another like bungee jumping.
Bungee jumping?
Yeah.
Yeah? Yep. Or the opposite of bungee jumping, which is what I was thinking of. If I throw my frog in the air, tell me about his acceleration the whole time. Ooh, that's a question. What's his acceleration as I'm throwing him up in the air? Say it loud, Gunner.
It's down negative 9.8.
Meters per second squared?
Yeah.
Yeah. Yeah. Tell me about his acceleration at the very top.
Yeah, right down. Yeah.
It's down negative 9.8 meters per second squared, right? Tell me about his acceleration as he's falling.
Yeah.
Down negative 9.8 meters per second squared, right? Yeah, we kind of talked about this before. We could draw a graph. In fact, I'd love for you to draw a graph. So why don't you get out a piece of paper so you can draw a graph of that? Because I think it's really important for you to understand that. So, what's what? Sure, if you want to do it on a whiteboard, that's fine. Yep. So I'm thinking about question number 2 up here. That was the one, can an object have zero velocity, non-zero acceleration? I would like for you to draw a displacement versus time, a velocity versus time, and an acceleration versus time graph for this story. I'm going to show you. Ready? Here we go. The time starts when I let go. The time ends when I catch it. So watch. Here we go. Woo! Just in the up and down direction. Okay? Displacement versus time, velocity versus time, acceleration versus time. Talk to your friends if you want. Talk to your table mates. Do it by yourself and then compare. What's it going to look like? This is an interesting question. I'm glad you asked, Ms. Carboline. Think about the motion. What's it going to look like?
Yeah. Oh, I thought you had it upside down. So I was like, that would be speeding.
This is a thinker. Love it. This is great. Yeah, that's okay. That's okay. It doesn't have to be perfect. We're just sketching. We're just sketching it. Let's continue. Let's continue. Right at the top. Yeah, there are no discontinuities in this graph, in any of them. Because if you watch it, right, it just keeps going. It just keeps going. Is the frog accelerating? Yeah. What force is causing the frog to accelerate, guys?
Force of Earth.
Force of the earth on the frog. Yeah. Force of the earth pulling down the thing we call gravity. And the acceleration that it's accelerating that frog with, right? Fg is equal to mg. Oops. Let me see if I can write nicely here. The force of gravity is equal to the mass of the object times the acceleration due to gravity. Okay? And so we know that the thing that is doing the accelerating is g, which is negative 9.8, right? Does anything change that throughout this story? Does anybody ever turn off the earth? Or no? No. So what's the acceleration versus time graph going to look like? A horizontal line? Yeah. Because the acceleration due to gravity is not going to change, right? So let's do it. Acceleration due to gravity is not going to change. Where is it going to be? Horizontal line at 0? Down here? Yeah, it's going to be down at negative 9.8 meters per second squared. Here we've got constant negative values. If I've got constant negative values, that means I need a constant negative what on this graph? Slope. Constant negative slope. But I need to know my initial condition. Tell me about the velocity of the frog right after it leaves my hand. Positive, 0, or negative when it's leaving my hand? Positive. Does that make sense? Because it's going up, 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 up. So it's going to start up here somewhere. And again, we're sketching. I don't care about the number. And it's going to have a constant negative slope. Constant negative slope. What does this point right here represent, ladies and gentlemen? Very top, right? Yeah. Because the velocity at that point is 0. Top of the trajectory. For sure. All right. Tell me about the values of velocity. The values here are positive and constant, or increasing or decreasing? Positive and decreasing. The value here is 0. The value here is negative and getting more and more negative. Are you with me there? Okay, so that means the slope here needs to be getting positive and decreasing. Eventually at the top it's going to be 0 slope, and then get more and more and more negative. It's going to look like a what? Parabola. Indeed. This point right here, where you have a slope of 0, is the very top, isn't it? The very top of its trajectory. Can an object, we were answering that question, have 0 velocity and non-zero acceleration? Non-zero acceleration, 0 velocity. Driving your car, or rolling your car down a hill, okay? But applying gas to go back up the hill, for sure. Can an object have a 0 acceleration and non-zero velocity? What's an example of that? This one?
No.
I was gonna say,
No.
this one has a non-zero acceleration, right?
No, like this physical object.
That has a zero velocity.
Oh, zero acceleration.
I want zero acceleration, non-zero velocity. Nick, go.
Constant, yeah.
Graph, say that green dot is like 3 seconds, and so at 3 seconds there's a velocity of 0. But on the acceleration graph, at 3 seconds there's still an acceleration.
Wait, say that one more time.
Well, when the question like, applies to some example of 0 acceleration. Oh, sorry, I was thinking of the second question.
Oh, that's okay. So I was like, I think you're answering that question. Can we think of an example when we have a zero acceleration, non-zero velocity? Abhishek, what you got? Constantly walking, constantly rolling, constantly driving, constantly anything, right? As long as you've got constant velocity, you're good. Yeah. We doing okay with this? Okay. Questions on the homework. Were there any of those homework problems that you did yesterday, last night that you would like to go over? So that would be 50, 52, or 54? Yeah. 50, you said 52?
Yeah.
52 and 54? Okay. And I probably won't do all of them, but I will certainly start them. Does that sound good? Let's start 52 here. 52. A football is kicked straight up into the air. I don't know how effective that's going to be for, the footballing, but that's okay. And it hits the ground 5.2 seconds later. Okay, so I'm going to write down what I know because I'm always going to start with my givens. It's much better to do it that way. So I know that the time is 5.2 seconds. It says, what is the greatest height reached by the ball? So I'm gonna write that as D max. Is that okay? I'm just kind of trying to figure out a way to write that down. Assume that it is kicked from ground level. Okay, so if I'm trying to imagine what's going on here, so here's my ground. There's my football at one point, and it's going to go up some height up here, and it's going to travel some distance, and that's what I want to know is that D max, like how high does it go? And how in the world am I going to solve that problem? That's the question, isn't it? Any inclinations, ideas, or directions? What you got, Elizabeth?
So if it hits the ground again at 5.2,
Mm-hmm.
its peak was in the middle.
Yeah. At 2 point what? Or did you say something? I didn't hear what you said. Can you say it?
2.6.
At 2.6. Where did you get 2.6 from?
It's halfway between 0
Does that make sense? Takes 5.2 to go up and come back down. So it's going to take half of that time to go up and half of that time to go down. It's all symmetrical. So I think I love that. So instead of writing 5.2, I'm going to say, all right, that's the total time. And I'm going to just go ahead and write another one. I'm going to say the time to go up is going to be 2.6 seconds. Awesome. All right. So now I've got the time for it to travel up that D max. What else do we know? I've got two hands coming up there. You guys can rock, paper, scissors, forward, or just talk. The acceleration is going to be negative 9.8 meters per second squared. Awesome. What's that? I could draw an acceleration graph? For sure, like an acceleration versus time. Is that what you're thinking? Yep. Absolutely, I could. What is the acceleration versus time graph going to look like? Right? Down below the axis? Something like that. Awesome. All right. I need more. Rudy, what else you got?
The velocity at 2.6 seconds is 0.
The velocity at 2.6 seconds is 0. Does that make sense? That's true. What am I going to do with that piece of information? The velocity is 0 somewhere. Often when we think about this problem, we think about timing it on the way up. It's going to take 2.6 seconds. But what else is true? It's going to take 2.6 seconds to come down. And if you focus on that second half, then the initial velocity of your football is what? 0. So I'm going to write that that's the v at the top, okay? I'm going to call that my initial velocity, and I'm going to look at the football falling down. Do I have an equation that has a displacement, a time, an acceleration, and an initial velocity? You've all got equation sheets. They're bright yellow so you won't lose them, right? I did that on purpose. I didn't make them on white because that would get lost in the shuffle. Take a look at that fancy equation sheet. There you go. I had a couple extra. There you go. Do you have an equation, ladies and gentlemen, that has those 4 things in it? The answer is the affirmative. Yes, Miss Carpenter, I do. See if you can find it. Talk to your table mates. See if you can find it because we got to
I don't know.
Did you find the equation? Did you talk to your table mates? Which equation did you choose? Can you keep me in the loop? The first one, the second one, the third one? Liam, which one did you choose? Is there anything else in that equation besides the half AT squared? Yeah, what else is in there? Yeah, I'm going to write it out like that just so that I know that you know where I got that from. On the equation sheet, remember I write them a little differently than they do on there. It's the second equation down. That x and x naught is really just the difference in position that I'm calling d, the displacement, okay? VIT is, they call it V naught, but it's the same deal. And then 1/2 AT squared. Liam was clever and said, oh, but I know that the initial velocity is 0, so I'm going to get rid of that, okay? And then we can solve for d, I think, right? D is equal to 1/2 times negative 9.8 meters per second squared times the time, which is that 2.6 now. Don't forget to square it, because if you do, it won't come out right. Okay? How are we doing, team? Did you want to look at 54 as well?
No.
You sure?
Yeah.
Okay, cool. All right. Anybody else want to look at 54 or 50? Either of those two, I'm happy to do them. No? Okay. I am changing my mind just given the time. I don't want to rush through collecting data. I feel like that would be an unhealthy experience for us, so we'll adjust that. I'm going to do should we do a couple more problems? Do you guys feel like that would be helpful, or do you feel like that would be a waste of time? Couple more problems? Okay, let's do that. Oh, that was really easy because you just did that. Oh, there you go. You can do this one. This one's kind of related to the one we just did, but go ahead and give this one a shot. A ball player catches a ball 3 seconds after throwing it vertically upward. Oh, the second half is very similar to what we just did. So that one should be kind of a nice review, but it'll be a good one for you. The other part of the question, with what speed did he throw it, is very interesting. So I'm going to let you guys play with that for a minute. Talk to your table mates. Start with your givens and a picture, okay? I told you when we first came up with these equations, the math here is pretty straightforward. The thing that's really important for you, ladies and gentlemen, is writing down the givens and understanding what the problem is asking. Okay? So I'm just going to give you a couple minutes to work on that because I don't want to just tell you what to do. I've got a couple other problems too, but I want you to chill on this one for a couple minutes.